If I were to look at some problems with significant figure, this would be an example of a significant figure problem that I have done before. And one of the reasons why I don't like to randomize, use sig fig problems to randomize questions is because if we were to go ahead and look at this, what a preview looks like, when D2L writes out numbers in scientific notation, it writes it with this up caret. And to me, that screams 1970s and 1980s. That doesn't scream 2020 to me. And I just am really annoyed that D2L hasn't figured out how to write out numbers in scientific notation using exponents. So when you see it written in exponents like this right here, that's the way that I've written out. I've chosen to write this as superscripted, and that's because I did not put the random number generator in here. I've had, I simply put them in as superscripts myself. But if you were to use the random number generator for sig fig problems, this here is the way that D2L writes numbers as significant figures. And so really significant figures to me are scientific notation problems. And so numbers that are presented in scientific notation and numbers in which answers are presented in scientific notation, if that makes sense at all.
Okay, so I always thought when you said sig fig questions was any type of question that dealt with dealing with sig figs, but when you really mean scientific notation and the fact that D2L doesn't have a way you like to present scientific notation numbers.
Well, actually, if you would look at significant figures and look at what it is, you'll see that it's actually a times 10 to some power. So if we were to author a real quick question, something like this, let's say we'd like to know what is the product of, and let's say that we want to take two numbers that we want to multiply together. Let's say that we want to multiply together x times y. Now, when you put the numbers in curly Q brackets like this is an indication to D2L that it is going to be calling a variable. So anything that you place into these curly Q brackets here, that calls a variable that has these very specific names. And so if I went down here then, if I've told it to expect these variables, then I have to define what those variables are. So I'd come in here, and at this point, I guess I don't put them in curly Q brackets. I'm just telling what the variables are. I'm calling them x and y. And this is what then I define what the range of those variables would be. Now, again, this is supposed to be a significant figure problem, but as you can see, even though it's a significant figure problem, it is expecting values in scientific notation. So that is the way that D2L handles significant figures. So as we know in chemistry, when we talk about significant figures, we're talking about whether they are in scientific notation or not in scientific notation. In fact, we usually have them not in scientific notation probably more often than in scientific notation. So
I was going to say, it's probably a bad labeling of a type of question, really.
Well,
whoever put that in, because it's really not a sig fig question, really.
Yeah, though it is sig figs, this is the only way, however, that D2L handles significant figures is that they have to be in scientific notation.
Got it. Okay.
So if I then wanted to do something, let's say that I wanted a range here of values now that goes somewhere between 2.5 times 10, and then this is where I'd say the power. Let's say it's 18, and I want to then go to say 6.5 times 10 to the 18. Then this here tells how I would randomize those values. So let's say if I wanted it to go, I wanted all of the possibilities between 2.5 and 6.5. Then my steps would either be written as 0.1 times 10 to the 18th, or I would have to write it as 1 times 10 to the, what would this be, 17th as my steps. It will take it like this. I prefer to keep all of my exponents in the same at the same level. And then maybe for y, I would say that this would go anywhere, and again, I'm just making up random values. Let's say this would go from 3.3 times 10 to the negative 44th, all the way up to 8.8 times 10 to the negative 44th. And then I want to do this in steps of 0.1 times 10 to the negative 44th. Now at this point, if this is just a multiplication problem, it is going to take this out to 2 significant figures, and that matches what we'd have if I would have this like as 2.55 up to 6.57. Then of course that has 3 significant figures. I would then change this to do a calculation out to 3 significant figures. So this is here where you specify the number of significant figures that there are in your values. And then it will grade it right or wrong based on even if you have the incorrect number of significant figures. But if you want to have a deduction for an incorrect number of significant figures, this here is where you can decide then what percentage of the value of this problem would be due to incorrect significant figures. And for me, you know, it's usually 10 or 20% as a deduction for incorrect sig figs. And then there's a plus or minus 0.5 from the least significant figure. So that will take into account then if the correct value is supposed to be something like a 6.6 times 10 to the whatever power, it would accept any answer between 6.55 and a 6.65 if the correct answer is supposed to be a 6.6. Yes.
Question. So
Yeah.
if this whole thing is about you're testing on significant figures using numbers in scientific notation, why would you only take off 10% if it's incorrect sig figs, if that's the point of the question?
It doesn't really matter. For me, it's not that necessarily, but I'm just saying on a problem, if I were to use significant figures in there, a normal deduction would be 10% for me.
And what do you use it for? Just to see if they can use scientific notation and get the right answer on their calculator?
Well, no, it's because all semester I emphasize significant figures. Mm-hmm. And so throughout the semester, if they have an incorrect number of significant figures, but they're close to the correct value, then I don't want to deduct half the credit
right,
for something.
I that.
Right. So
I was looking for this question specifically because.
No.
Okay.
No, this is not a testing on significant figures. I'm just showing a significant figures problem.
Okay, got it.
So then if you want to calculate this, what I would do at this point. So now we need to put the formula in. The formula is different than putting a formula into Excel. If we want to show how it's going to calculate it, we would actually put in the curly Q brackets. We're going to tell it we're going to take X in curly Q brackets times Y. And so we use the same operators that we'd use in Excel. It's just that when we put in the formula, we don't put in an equals sign here like we would in an Excel formula. Otherwise, it's just like you would write a formula out in Excel. Then if there were units, you could put in units here and then decide, you know, how much of the problem that they are worth. And so at this point, you'd be ready to preview the problem. So we go ahead and preview it. And you can see here why I don't like the sig figs, because if you look at these numbers right here, you'll see that they're written with up carets rather than writing them as exponents. And so to me, this looks like the 1970s and 1980s. It doesn't look like 2020 to me. So I think that, you know, if we teach students how to write with exponents and such in their lab reports and whatever, we should be able to have it when we tell them that importance, that D2L should place that same importance on it. So there's a number of reasons why I don't use it. That's one of them. Another reason is that anything with significant figures is forced to be placed into scientific notation. So
interesting. I didn't know that.
So if I want to do a significant figure problem, I always do an arithmetic problem, and then I have to keep in mind the types of possible answers that students could have. And so I always then write out an arithmetic problem and specify, make sure that if I calculate something that's supposed to have 3 significant figures, that I don't have a possible result that could show up as 4 significant figures. Because if you author a problem that's arithmetic, you specify decimal places that the student's answering and not the number of significant figures.
Yeah.
So
that's what I call the significant figures, is because you change the number of sig figs for what you want to test on, like 1 or 2 or 3. And that's why the name of this is called sig figs, even though all the numbers are scientific notation. Because the name of this does not make sense to me as a person who knows it's sig fig, you know, like that's only because of how you end up changing this, how you change your range. And that's why they call it that then.
Yes.
For everything else, when you do those arithmetic ones, you have to go by decimal places. Yep. Okay, that's clarification. Okay.
What I'm going to show next then is how I would author a significant problem, sig fig problem, if I were writing one out like we would see on this first exam. So I'm going to write out an arithmetic question. And in this question here, we are going to determine the height of a high-rise building. And we're going to convert it from feet to kilometers. Okay, so I have already authored one like this, so I'm just going to copy and paste for the interest of time over here rather than showing you how it's all set up. So this is what a question might look like. It says a high-rise building in downtown Minneapolis is X number of feet tall. What is the height of the building in units of kilometers? And then you'll see that in the answer box, it says express your answer to 3 significant figures, give the correct units in the units box. Okay, so this is how I'd word it. Now, this is my choice of naming the variable. I could have called it anything I wanted. If I wanted it, I could have called it X feet. Sometimes when I'm just playing around with this is just my reminder that when I go to create a variable that I'm putting stuff in feet and not putting in accidentally putting it in kilometers and having it convert kilometers to kilometers, so to speak. So this is just my reminder to me when I'm writing these out what to look for. Okay, and I don't remember if there's a limitation on the size number of letters that a variable can have, but in this case I'm having the variable have 2 letters. So I'm going to come down here and label that variable in feet. Now, of course, if we were to think about how this might occur, now I don't have my tablet PC hooked up here, but if I were to bring out a list of conversion factors here real quickly, which I can pull up. So if we think about this, there'd be a couple of different ways to do it. And as we know, it doesn't really matter if students would look at this and say, well, I'm going to first convert from feet, then to meters, then to kilometers. Or perhaps I'd convert from feet to miles and then to kilometers. In the end, we know if we're looking to 3 significant figures with the conversion sheets that are provided, it doesn't matter. So I would look at this and say, well, we know then that in order to convert, I will go from feet to miles and then from miles to kilometers. So if I go from feet to miles, we know that there's 1 mile for every 5,280 feet. And then if we wanted to go from miles to kilometers, we have for every 1 mile, there's 1.609 kilometers. So as I think about this and put in my formula, of course, what that means is we're going to take the number of feet, which I'm going to write out that variable right now. And we are going to multiply that by 1 over 5280. And yes, I know we could simply divide by 5280, but when I write out my formulas, I often put them in the format as if we were doing conversion factors, just to remind me that when I come back and manually grade it, how I set it up and how I look at it for students, I can just do the quick look. And then of course, we're going to multiply by 1.609. So this here is the formula. And now I need to consider, well, how the heck tall is a building? So now I start putting in my values here, And I say, well, if I do this, I would go ahead and grab my calculator and I'd start running some sample numbers through this. I might put in a height of something like 300 feet. And so this is where I have to do it manually, or sometimes what I do, and this is actually how I wind up doing this now, and that is I create a spreadsheet. I'll expand this a bit. And so I'm going to put in here feet and kilometers. No, let's see, how do we do it? Feet and kilometers. Here's how I wound up doing this. And so I start putting in values. I might test something like a 300. And then I'll put in my formula, take the value over here, divide it by 5,280, multiply by 1.609. And so when I do this, I see what this value is, and I might then write out a high number like 900 and just copy this down to see what my range of values might be. Well, if I want this to be a significant figure problem, what I see right away is that putting a value of 300 and 900, this range is not going to be very good, because remember now, I'm limited. If I put them in this form, I'm limited to doing these as decimal places. And so if I would put something as, say that my precision is going to be 3 decimal places, well then this 300 feet is going to be too small, because out to 3 decimal places, it's only going to round it to 2 significant figures. So what I do then is I start playing around with values, and I start writing in, well, what is the smallest value I could put in? And I say, oh, wow, 333 works. So I try 331. I see 331 works. If I go down to 329, 329 works. And so I just basically go down to see, well, what is the smallest value I could use? And you see now, once I get down to 325, that's too small if I'm going to go out to 3 decimal places and have 3 decimal places serve as 3 significant figures. Does that make sense?
Totally. And I already dealt with some of this last semester myself. So
Yeah.
I have one question for you though. So if
Yes.
you type in 900, you know, that right now, if you just don't have a decimal point in, that's a 1 sig fig number based upon all the rules. So you have to write 900 point then, or what?
Okay, so here's what I do to get around that. I'm going to look at the smallest value. It looks like the smallest value that I use is 329. It looks like I could go up to 999. Okay?
Okay, yep.
So
okay.
these have 3 significant figures, and then if we're going to round off to 3 decimal places, these rounded off to 3 decimal places. I'm even going to show it here in Excel out to 3. Whoops, wrong way.
Yeah, I get it now then. You just don't use the numbers that don't have zeros at the end then. You just non-zero numbers. Okay.
Yeah. So then what I do is I would say my range is going to go from 329 up to 999, and it's going to have 0 decimal places. And now I'm just going to have it step by 2. And that way it always forces it to be an odd number, and an odd number is never going to end with 0.
Okay, that sounds good.
And so then at this point, I'm also going to pull over my units. My units are going to be in what's called a regular expression. I'll put this on a word processor here so you can see what this regular expression might look like. So I'm not going to give a lesson because that's an entire hour by itself. But basically what this...
I would probably like a lesson on that at some point. Not today, but I would like a lesson on how to do that, because that was something last spring I didn't understand how to do.
Yeah, well, what you can do is you can do a Google search on regular expressions.
Yeah, Google search. Got it. Okay.
Yep. And if you Google search regular expressions and then even Google regular expressions D2L, then you'll find what they might all be. But what this would accept, if I would just do a quick rundown, is that this would accept either an uppercase K or lowercase k in the first position, in the second position a capital M or lower m, and then the $ means that they could put something afterwards. So if they could put something kilometers, km, building, or whatever. So no, I think this must just truncated at this value. And then this here would accept either a capital K or lowercase k with kilometer, and then it would account for the 2 different spellings, either an ER or an RE,
okay,
with an S at the end. And again, I'd have to look up what the $ and the question mark mean.
Mm-hmm.
But each of these vertical lines here represents different types of solutions that it might accept.
Okay, got it.
Okay.
Okay.
And when I first started authoring these, there's some people that always like to shout and put everything in all caps. And so then I would allow somebody who would put in all caps as an acceptable answer as well.
Okay.
Okay.
Mm-hmm.
But at this point then, I think, let's see, we want to enforce the precision. The tolerance now, since we're going out to the thousandths place, we'd accept the tolerance of plus or minus 1 in the last digit. And then my regular expression, I'm going to paste in here. And we'll make that worth 10% of the value. Now, what I've always done, because look, no matter how much you tell students that they should pay attention to significant figures, they don't, and they're going to write down the bazillion number of digits their calculator gives them. Not only do I expect that they know significant figures, but if I tell them to give their answer to 3 significant figures and they don't put in 3 significant figures, because we enforce the precision here, they're going to get 0 credit if they don't have the number of correct sig figs. So these are ones that I will go back then, and I do check all of the manually answered questions or the like fill in the blank type ones. I do go back and check all of them manually. This way, however, anything that's marked wrong, I can look at it really quick, and I can go back and give them some partial credit if they have the correct answer but the wrong number of sig figs. And so I usually deduct 10% for incorrect sig figs on a problem like this as well. So it's a minus 10% for incorrect units, and then a minus 10% for incorrect sig figs. But I have to manually score that myself.
Right, and I've done lots of that before on D2L quizzes before. I have another question for you.
Yep.
Okay, so you have a feet variable and you have a kilometer. You have kilometers over here in your question, also in the squiggly or the curly Q boxes, right, or not?
This is not in curly Q.
Okay, good. That's why I was making sure, because you only have one variable, really.
There is only one variable.
Okay, so down below you don't need 2 boxes then. You probably just have to get rid of one then.
Right. In fact, if I were to go ahead and try to preview right now, and you notice that it's empty, I go and preview, it'll say, oh, you have these errors in there. Okay. And so just like you asked about, we only have one variable. We need to delete this one here because it's going to look for a second one. At this point now, I can go ahead and preview it. And you'll see then that it's placed one of those randomized values in there. And this is the answer that it would expect.
Right, where did you delete that again? There's a delete button over there, right? That you just deleted?
Yeah, there's a way out here on the...
Add a new one again. Just add one really quick.
Add a new one. And so there's a trash can
over there. Okay, got it. Okay, so
get rid of the variable.
Okay.
So at this point then, if I wanted to preview it, whoops, I added in, that's right.
Gotta delete it again.
Got to take it back out. We can preview it.
Okay.
We see now it's generated a new question out to 3 significant figures, and we have the 0.137 as the result this time. And so if I wanted then, all I have to do here each time just to check it, I could try just a number of randomized results just to make sure that it works. And usually I check it 2 or 3 times then to make sure that it is indeed randomizing and randomizing the way that I want it to randomize. So at this point, it's done. We can go ahead and save this question. And we've then put this in here. And so anybody that's watching this video, if you're watching it later, I'm saving these questions that I've authored here into this data bank. It turns out both Rita and Amela are gone today, and we're not able to create a course that I could add you to. So for right now, I'm putting this in a course, and then once they get back on Monday or whatever and create a course, I will import these questions over there for you to use. And right now, if Patty, you or Howard wants this, you're already a part of this course. You can have access to the ones here that we've just authored in our shared course.
Oh, this is our online lab course. Okay.
Right.
Sorry, I can get in here already.
Yep, you can get into this one already.
Okay.
Okay, so any questions on authoring sig fig or arithmetic type questions?
So just when you go back to, even though I've done this before, it's been a while. So when you went to do this in the first place, you went under, just go back to the whole beginning step. You go to,
well, here's another thing, as long as you're bringing it up.
mhm.
I always author my questions in the question
Right.
library. Because if you author them in the question library, then what happens is when you go to write the exam,
Mhm.
it's a lot easier to create a question pool and pull from a whole bunch of questions that have already been authored and
Right.
randomizing them or whatever else.
Can you go back from the very beginning, like how to get back into that again? Just when you go, like you're just in your main course, the
So
main page, and just going back into that. So quizzes first.
assessments,
Quizzes,
quizzes,
right?
then I'd go to the question
Question library
library.
right there. Okay.
And here now I'm going to author them inside this section that I call the D2L Question Authoring Workshop. You then create a new question. So you create an arithmetic question,
Right,
title it,
there.
write out your question, put in your formula, specify the precision. I always choose to enforce the precision. Then you want to set the tolerance. Make sure that your tolerance matches whatever the last digit is. So if you want it out to 5 decimal places, then you are going to specify this here to go out to 0.00001.
Okay, another question. When you made a new folder up there for this D2L this workshop today,
Yes.
you made the folder up by when you go back to, okay, so you go to assessments, quizzes, question
Assessments,
library.
quizzes,
Okay.
question library.
And then
Yep.
how did you make that new folder up again? Is there a new folder
Click
in
on
it?
new and then
There you go.
section.
That's what it is.
Yep.
So you make a new section, and then once you click on that new folder, where you name it what you want, and then you go on and author all your questions in that folder.
Yes.
Got it. Okay.
Yep.
I've done this before, but it's been a while, so.
Yep. Okay.
Okay, that's good.
Yep. Any other questions that you have on that?
No, I've actually done some of this already myself last
Mhm.
spring, so I'm not totally newbie on it. And I have also made new sections like this in the question library. It's just been a while, so it's a little refresher for me.
All right. Here's another example of one that we might use. And I do this to help avoid cheating. So you're going to help me with this one here. And in fact, if you want to author one on your side while we do this, I am going to create a new arithmetic question. And it's going to look like this. In fact, let me just zoom in a bit so you can see this a little better. To prevent some cheating, because students, if you want to do like a percent by mass composition, all a student would have to do is do percent of sodium in sodium carbonate in a Google search, and that would return the correct answer for you. I don't know if you knew that, but
I know that you can find almost everything, many things on Google, if it's a known topic.
So if we did this right here, see how quickly that was returned? There's your answer. They don't even have to Google it. So what I've done then is I've gone to creating questions of fictitious compounds to reduce the chance of that happening. And so this is just a fictitious compound that I've made up. And we want to find the mass percentage of that compound. And so now if we think of how something like this would work, we could have a formula that looks something like this. In fact, I'm going to go ahead and copy and paste that formula over right now. But basically what we're doing is we're going to take the number of sodium atoms, which we have a subscript of X, and the number of potassium subscript of Y. We're going to take the number of sodium atoms, multiply it by 22.99, which is the atomic mass of sodium, and then we're going to divide that by the sum of the two masses. So it's the number of sodium atoms times the mass of sodium plus the number of potassium atoms multiplied by the mass of potassium. That's a percentage. We get that, correct?
Yes.
And then we multiply that by 100. So now when we do a percent by mass composition, it's looking like we have 4 significant figures here. So in a percentage, how many decimal places are we going to want? Probably not 1, we want 2, right? So I want to be sure that when I set it up though, that I set up kind of something that we're sure is always going to be 4 significant figures in there. And of course, then we're going to want a tolerance of how much?
Plus or minus 0.01.
Right, okay. And now the units that we'd put in here, I'm just going to say 0% on this one. Oh, that's right. They aren't going to put in units because in this case here, I've already specified them. And that's one of the things I've learned is that percent symbols, because they are sometimes used in like regular expressions and everything, I've found that they can sometimes screw up units. And so very often I leave, unless you are doing like a case insensitive one and you know for sure it's just going to be percent, you can put that in here. But if you start messing around by putting something like a percent symbol in here, you risk the chance of perhaps causing an issue with regular expressions. So this one I don't bother with the units.
Right, and they might write the word percent instead of percent symbol as well. So it's, yeah, I see your point.
Yep.
Not that important to have the units in.
So now, remember I have X and Y, and I could have any range of variables that I want, but I don't want the variables to be the same. So I'm going to make the X values be even, and I'm going to make the Y values be odd. So if I want,
why don't you start at 1 instead of 3?
well, because when you see a formula, you don't ever see a formula. We don't write H2O1, do we?
Oh, that's why. Okay.
Yeah. So we want to make sure that it's the way that we as chemists would write it. So great question. See, anybody watching this now, they might have that same question. And so we already answered it for them. Nice job, student. So if we now want only to assign even values here, what step would we put in? Very good. And how about for the second one? Good. Good thing I can see you on camera. I don't know that everybody else can, but our student Patty answered 2. Very good, Patty. So at this point then, I think we are just about ready to...
Okay, I don't see anything.
Now see, sometimes I would still make a spreadsheet. I would look at sodium atoms over here, I'd look at potassium, and then I'd put a range of numbers to just play around with them over here.
It's wrong for potassium, just so you know.
What's that?
You put Ka accidentally for potassium.
Oh, okay.
Doesn't matter that much, but I just noticed it.
Yep. But I'm not going to do that here, mainly because I know that by choosing these subscripts here, I've kind of already done this in my head. I know that I'm not going to have any molar masses larger than 999, and I'm not going to have any molar masses less than 100. So I know just doing this off the top of my head that my molar masses are all going to be somewhere in the range between 100 and 900. But if I was dealing with some elements that I wasn't sure of, just can't do it quick enough in my head, I would sit here and do some sample calculations with a spreadsheet, just like I did with sample values here for the feet to kilometers. Okay. So let's go ahead then and test this out. We will preview it. And it looks like this turns out to be a good result. Again, we'll click done. We'll preview again. That looks good. And sometimes, again, what I'll do is I'll always go over here and just check out, might put in like 2 sodiums and 3 potassiums and write that formula in over here just to make sure it works. And I might then combine it with a max of 9 and I put a max of whatever it was here, 8, and just calculate what the percentages are. I look at what the minimum percentage would, I guess the minimum percentage would be when sodium is 2 and potassium is 9. And the largest percentage I could have in my form. So I suppose we might as well just do it real quick since I'm talking about the possible scenarios. The largest it could have been is 8 with potassium, lowest of 3. And so if I put in my formulas real quick over here to test it, so I don't have to rewrite this, I'm going to copy this. We'll paste it over here. Oh, that's just going to be more work than necessary. We're going to take whatever is in this cell right here, and we're going to change this to A6, and we're going to change this here to B6. So that's the lowest percentage it could be. This is the highest percentage it could be. So I guess it's always good to check it just to make sure that when you have decided here that you wanted this out as a precision of 2, that in fact it matches that. And it looks like we were actually pretty darn close. If we'd gone up to 11 on this one, we see now that we would have gone down, and specifying only 2 decimal places would have given us only 3 significant figures when we wanted 4. So that's how in advance I would look at and why I select the ranges that I do. And so now what's really nice about a problem like this is that I could go ahead and save this. Oh, and I forgot to give this a nice simple title, so let me go back to it. So I'll just go this percent NA in NAX KY. So we'll save that. And what's really nice about this now is that if we want to kind of shake things up a bit, I'm going to save and copy. And now what I'm going to do is I'm going to change these around so that sodium will go from 3 to 9, and potassium will go from 2 to 8. And so now I've just generated a new set of questions. I'm going to make sure that these work over here. So the lowest sodium could be is 3, potassium could go up to 8, and here sodium could go up to 9, the lowest potassium could be is 2, just to make sure that they are within the range. So again, I'm using my spreadsheet here as kind of a test to tell us that they're in the range. Do a quick preview on this, and we get the correct result. Now, part of why I do it this way is I want to avoid the whole empirical formula versus molecular formula thing. So I don't have them where they could accidentally generate the same subscripts, okay? Because if they generate the same subscripts, that's just like finding the percent of an NAK. So by default, the subscripts would have each been 1. Mm-hmm. So I'm trying to avoid a situation where the results are same, where they could have maybe accidentally just found the percentage of sodium in an NAK formula without taking the subscripts into consideration.
Right, which is why you made sure you had those numbers then. Question, are you going to change your title then to like number 2 or version 2 or something?
Right, so then I'll just call this B, and then I'll save that. And now you see I have these 2 questions that are available. I might then go back and just quick call this a version A to realize that I've made the 2 types.
Okay.
And then if I really want to make this into another type, because of course, if students are sharing between sections, they say, oh, hey, I had a percent sodium problem. Well, then what we can do is we can yet create one more problem. So we're going to do a save and copy. And this time we're going to change this to a percent of potassium in this problem. And now help me out here, Patty. How are we going to revise this problem?
Scroll down to the equation.
Yeah, what else do we need here?
Well, change that to a K, of course.
Yeah.
Okay, so now let's go down to the problem. So we're going to do, change it 22.99 that's on top to a 39.19.
10, correct?
10, sorry. Yep. And now change the also the other 22.99 also to 39.10.
Well, that's one way we could do it, but remember these
now we're calling X our potassium now, unless we change that to Y. Okay, change that to Y instead then.
Yeah, if we change it to Y,
then you're done. Okay.
Then we're done. Exactly.
Y was already K anyhow, down below, right? Yep. Okay.
Yep.
So.
Yep. So now then
we might as well keep it, because you're going to keep it NAK, and now you're going to, since NA is X and then K is Y, then okay, that's the easiest way to do it.
Yep. Yep. So you just think about it, and then again, I generate a few different previews to make sure it works. And then I'll come back to here, and it's like now we're doing a sodium. So I'm going to change this from an A6 to a B6. And I think that took care of it.
You gotta change that 22.99 to 39.10.
Yep.
Okay.
That takes care of it.
Yep.
And then we'll drag it down from here. So now the largest K could be is 8. And the lowest, so this would be such a scenario. And then of course I could create still one more version of this. So this is now my version A. So we're going to save that.
And then,
And then we're
going to numbers changing again.
And so then we're going to save and copy. And I'll make a version B of this. And in our version B, what we're going to do is we'll swap this around to a 2 and 8. And we'll swap this around to a 3 and 9. And then again, I want to make sure that that works because now my sodium can go anywhere between 2 and 8. So this can go between 2 and 8. And this can go anywhere from a 9 down to a 3. And again, just making sure that my values here fall within that range. And so again, preview it here just to make sure that you haven't broken anything in doing so. And what I sometimes do then just to confirm that I've done it correctly is I will come over here to my formula that I created and I will put in the values. I'll put in an 8 and 7 in here and drag this down one more time just to make sure that the value that is showing here matches the one that I'm showing in Excel. So you see how I'm matching them up there?
Yes, I see that. You're matching your numbers from the question into your Excel.
And so I just do, this is a way that I go through and double check and double check and double check my answers because of course, once that quiz starts, unless you're sitting there and watching every student complete it at the very beginning, you don't know what possible errors you have in there until I've gone through. So I still have errors that get into mine, but by doing the dual thing with Excel and D2L at the same time, I've found that I eliminate errors up front.
Well, I know from experience from last spring that if you do a little extra work in checking things before you put it up, it saves a lot of time trying to fix things after the students start taking a test, right?
Yep. So now, one of the items that I had on here on this workshop for today was to duplicate questions and generate question pools. So we've shown how to duplicate questions now simply by changing one or two things here very quickly. So let's show then about how to generate question pools. I know you know how to do this, Patty, but
it's fine to go through it again.
We'll do it for anybody who's watching this. So now, is this my quiz? Maybe I've not generated this quiz yet. So let's generate a quick quiz here. And I must have forgot to add it in here. So let's do a practice quiz. This would be a good practice anyhow. Let's make a new quiz and we'll call it our D2L workshop quiz. And what we're going to do now if you wanted to, you could put this into a category. We'll just call it, we won't put it into a category right now because I don't want to mess up anything that you may have done. We're going to add some questions to this. And at this point, we are going to add a question pool. And we're going to call this % composition.
Quick question for you. Did
Yep.
you have the updated version then of how you make question pools? Because I feel like mine was different before.
I feel like this is the first time I've ever seen this. So I just made a lucky guess where to pick it from because I haven't seen that menu before.
Okay, because it looks different from the last time I did this. That's why I'm asking. Yep. Okay.
Yep. So now we're going to browse the question library. And we're going to go into the questions that we created, which of course were in, I suppose, here we go, our question authoring workshop. We want, did we forget to save that last question? I bet we did.
Yeah, I think you did. I think you just did a checking it, making sure it was right, but.
Yeah, but I bet we didn't save it, darn it.
Well, go back and do it quickly because, I mean, at this point, then you'll have the question
let's
made.
go ahead and generate that one real quickly. That would be a good, I'm glad we made the mistake because this is mistakes I make all the time. And so we'll come back to this one here. And of course, oh, we need to save and copy. And that might have been what I forgot to do last time. We'll go to version B. And of course, to go to version B now, we're going to change these to 2 and 8. And this one here to 3 and 9. And we'll go ahead and save that. There we go. Now we have our different versions. Of course, the one thing I didn't do this time when I changed it is I didn't preview. Remember, it's always a good practice to go in and preview. I like to preview at least a couple different times just to make sure that it's doing what I want it to be doing. It looks like I even have these results that I had here last time. So we'll go ahead and click done. And then we're going to generate a question pool. So we are going to go to the quizzes, and there's our D2L workshop quiz that we started. And we're going to add some questions. And your question last time is, where did this come from? And this is the first time I've seen this. So go to the question pool. Again, it's going to be percent composition. And we're going to browse through the question library. We'll go down, we'll find that in the question library. And we want to use these 4 questions. We want to select one of these. So we're going to add this to our pool. And we want to select one of those 4 questions. And then this is where you decide how many points that question is going to be. If this is on an exam for me, I usually have a question like this worth 5 or 6 points in a 100-point exam. And we'll click on save. And there's your question in the question pool. And so we got a 1-question exam. We then wanted to add in another question. Let's say we wanted to go back and add in the other questions we added here today. We could add in our sig fig problem and our high-rise problem. We'll add these in. If we want both of these to be part of the test, then they just come in and they're part of the exam already. If we want to change the number of points on them, we can click on here. How do we do that? Oh, we go out. I think most of you know how to do this part here. One of the ways you can edit the values of the question is out here. If we want to edit this one to be, say, 3 points and something like this to be 6 points, whatever it is we wanted, we go ahead and add that out here and then save them. And then that would give us the number of points for those questions, whatever it is we wanted for those values. Now, about the only thing I haven't shown yet is I haven't shown the chemistry equation editor. And would you like to look at one of those?
Sure, why not? I've done some of that already too, but just put it on the video. Not a bad idea.
Okay. And so again, where's the best place to create questions?
Question library.
Right. So we need to go back to the question library. So go to quizzes. We'll go to the question library. We're creating them in here. Here's one that you might want to use on the first exam. Let's say we'd like to know how many neutrons there are in one atom of a given isotope. And pick out an element for me if you want.
Okay. An element that you can hear me? Okay, I'm
Yep.
not good. Let's do copper.
Copper. All right. So we want to figure out, we're going to write out a new question, and I'm going to put this in the form of an arithmetic question. And I'm going to call this neutrons in copper. Okay. So now my question is going to be worded something like this. My question might be, how many neutrons are in one atom of, we want to know how many neutrons there are in one atom of a copper isotope. So I'm going to go to my periodic table. So it looks like copper has an atomic number of 29. So if you've not used this before, the chemistry equation editor is right here. And there, it turns out there's a graphical equation editor. This is something that when it writes out variables, it writes out variables in italics. So this is more of a if you want to do a mathematical type equation and italicize your variables. In chemistry, of course, we don't want our chemical formulas italicized or our catalyst or whatever else. So we use the chemical equation, and this prevents them from being non-italicized. And you see there's all sorts of options in here. Of course, if we're going to do a isotope, we want to select this type of superscript here. And you can see there's all sorts of little templates of adding things in. If we're going to be doing something with catalysts later on, maybe you want to put something above an arrow. If we want to do equilibrium type reactions, we might want to have a double arrow, and I don't see a double arrow right offhand here. But you can always add in what's called a Unicode character if you've not done that before. That's something that's helpful to know. But I'm going to come back here to this one, which of course enables us to enter those in. And so in this position right here, I'm going to put copper. Of course, the subscript here is its atomic number. And we want to put the mass number up here, which of course we give with the letter A. So we are going to insert that into here. It's going to look something like this once it's all completed. And so now what this enables us to do is it enables us to give a large number of isotopes that are possible. Now, when I look at copper, I don't know all the isotopes that are possible. So what I might do in like this, I might look up isotopes of copper, just so I have some idea what the range are, isotopes of copper. And I might see that they go anywhere from copper 52 up to copper 80. So I'm going to come back here and I am going to put in for A the possible numbers that go anywhere from 52 up to 80. And of course, if we want all the possible isotopes of copper, what step do we want to put in here? 1, very good. And then if we want to put in we want to put in a formula here. So of course we called this A. What would the formula be that we'd put in here that would calculate the number of neutrons for us?
A minus, what was it? Let's see, A minus, I gotta remember the number, 29.
A minus 29 is the formula, great. What do we want to put down for the precision?
0 decimal places.
Right, and of course we want to enforce the precision on that. And this is one where I would put no tolerance because there's no uncertainty. It's going to be an exact number. So this one here, your tolerance should be set to 0. And of course, there's no units on here. Now, of course, it's showing 2 variables. What do we want to do in this case?
I missed your question. Well, get rid of that other variable. We don't need to.
Get rid of the other variable. And we should be ready to publish, but before we publish, what should we also probably do?
Check it in Excel.
We could check it in Excel, yes. Though this one's, I think.
Preview first. Sorry, preview first.
Preview it, yeah.
I thought you meant like before you preview, I meant.
Oh, now it looks like something's wrong here. That's not good. It's calculating it correctly, maybe. But it looks like we've done something incorrectly. Is it showing up as A? Well, I did this purposely because I've done this before because I wanted to generate a number of problems. And the way I would have done this before is I would have gone through and I would have generated a bunch of problems and changed this number. So, what could we do? So this thing right here takes you to the HTML source editor.
Wait, before you go on here, what was wrong with that? I don't know why it was wrong.
Oh, well, go back again.
Preview, okay, let's see. So you have the 20, so what was A? A was supposed to be?
Well, we don't know. I assume A here in this case would have been
42.
A probably would have been 71.
Right.
But we're not seeing 71. What we're seeing up here is A. So
right. What's going on?
What I'm going to do then is to show you how to fix this and how we might, well, first of all, we showed the chemistry equation editor, but here's how you can also use the randomized variables in here. I'm going to go through and find out where that darn thing is. And so I am looking for my random variable. Ah, here it is, math variant. And so I want that not to show up like that. So here's what I am going to do. I think what I want, and I'm just verifying this now in one that I've already written, is I want to get rid of, let's see, I want that squiggly brackets in there. I think what I'm going to do is I'm going to take this squiggly bracket right here, and I'm going to put it right there. Whoa. And here's my other squiggly bracket, and I'm going to put it right here. So what happened is that those squiggly brackets got moved somewhere else in the HTML, and they didn't get moved right around the A. And so this here, the squiggly brackets have to be next to that A in order for that variable to be randomized and generated. So now I'm not entirely sure that this fixed it. So I'm going to save this and see if indeed that it did fix it. Now, at least display-wise, it appears to be fine. Let's preview it. Ah, see now how that fixed it?
So let me ask you another question. How did you figure out the first time this happened to you to go into that HTML thing down there and to do that?
Well, it was a long process. I mean, I'm just a person that troubleshoots, and when I was going through it, I was looking for this A in the square brackets because I know that signifies, hey, look for a random number, and I didn't see it. And then I saw the squiggly brackets weren't together. So I went and then wrapped them around the variable, and once I wrapped around the variable, everything worked beautifully.
Learned the past by just trying it out, basically.
Yeah, well, and I understand some HTML as well. And so we'll go ahead and save it. And again, you just preview a few different ones and make sure it works. It looks like it's working beautifully. So this is one that we can all do in our heads real quickly. Again, you can generate a bunch of examples and just see then that it is indeed working the way it's supposed to be working. And so once I have that done, I go ahead and click on save. And let's go back now. First of all, any questions on that one?
No, it looks good, but I think I would never be able to go in. I would not be able to figure out to go into the HTML editor.
Well, now you know.
Now I know a little bit, yes.
Now you know, and if you always want to, you can model it around this one, because if we want another problem very quickly, let's say now we don't want neutrons and copper. Let's save and copy. Let's say instead we want neutrons in zinc. So now we're going to change this to zinc. And let's see, double click doesn't fix that. So I'm going to have to go in here and click on the chemistry equation editor. There we go. Pops that back in. So I'm going to change this from Cu to Zn. Oh, that's treating it now as a math equation. So I'm going to cancel that. I'm probably going to do this in the HTML editor. Now, I'm sure there's a way to do it, so I'm going to change this from Cu to Zn.
There's no way to fix that without having to go into HTML. Can't you just, isn't there a way to fix that directly in the?
Well, let's try it again. I think when we go in here and change that, let's try Zn. See, it's wanting to italicize that. So it's thinking that it's a math equation and not a chemistry symbol. So maybe
so maybe that was the problem basically with using this as a D2L question, is because once you have that A up there, we had to go back and you had to go and change it.
There you go.
Okay.
So here it is.
What did you do?
I'm clicking on this. This is italicized or not italicized right here.
Okay. And just take out the U then. Okay.
Yep.
And change 29 to 30.
Change 29 to, is that what it is? 30?
Yep.
Okay.
You picked one right after copper.
So we go ahead and do that. And then of course, since I'm not really sure what all the isotopes are of zinc, I come back here and do a quick isotopes of zinc. And I see that they go anywhere between 54 and 85. So I'd come back here and change this from 54 to 80. I mean, assuming that you want to keep it with ones that are possible, you may or may not want to do that. Nothing else changes. You can then do a quick preview, make sure that it works. Oh, see, we did something there that's still not working again. You see what's happening? Yes. I think maybe that's why I learned to do it within HTML before.
Okay, so to fix it again in HTML one more time then. Let's go.
All right.
The brackets again. So it went back.
So it went back.
Remove them again.
Where's my squiggly? There's the squiggly. We're going to move that back to here. So I'm just copying and pasting it. I'm going to take this and put it back into right here. And now we'll save it. Again, always a good practice to preview as we're learning. That's not correct. Why is it not correct? What did we not do?
It somehow didn't get that 29. It kept it 29 instead of 30. Oh, we didn't change the formula. That's why.
Didn't change the formula.
Right.
So now we change the formula. We preview it. And I'm glad we make a few mistakes because, again, it shows the importance of always checking your work and making sure that things show up the way that you want it to show up. All right, let's save this one. So now we have 2 questions here. Now we want to come back and put them into, where is it? We want to go to our quizzes. Now you help me out with this, Patty.
D2L workshop. And then we're going to do a add edit questions.
Yeah.
And then we're gonna import them over. So add, no, you import them, don't you? Oh no, add them from the question pool. Yep. Add them from the question pool.
Neutrons in isotope, we'll call it. Mm-hmm. And then we're going to browse our question library.
Scroll all the way down to the bottom.
Select these 2. We're going to add them in. These are the 2.
1 out of 2.
1 out of 2.
Make them 4 points each.
Oh, we forgot to do that. So let's see. We come back here, we click on it, and we want these to be 4 points each. Right?
Okay.
Click on save. And now we can go ahead and go back to our quiz setting. And tells us that this is worth 18 points. That Neutron's question here is worth 4. It's going to pick 1 out of those 2.
So going back again to the, okay, so you went, can you go back to the beginning again when you went to quiz? Let's just go through the whole process one more time. Okay. So back quizzes. Then you went to which quiz we're doing, D2L workshop quiz. Click on that. Then we did add edit questions.
Add or edit question.
Mm-hmm. And because we made a new question pool, we had to add a question pool.
Added a question pool.
Right. And once we name our question pool, and then we find our questions in our library and add them in that question pool.
Right. How many ever questions you wanted out of there. So I was reading your graduated cylinder. We'd put it in here. We'll add those. So we'd say read graduated cylinder. And then we want to pick one of those 2. We want to have this worth 3 points. We'll click on save. And now if we want to go ahead and see how we did, then the next thing that I would recommend doing is that you preview your quiz. Make sure that it is indeed what you want it to look like. Of course, you're going to set your other parameters like time and whatever else. So this shows you what the quiz is. And again, this is why I don't like these sig fig problems. It's just, and I think Andy found out here just yesterday, he sent that email out showing that the sig fig problems weren't grading them correctly. So I would avoid sig fig problems now until that issue gets fixed. And I just try to avoid them, period.
I have a question. Did you put it, when you did that sig fig question over earlier, did you do a 4, go back up, 77.300? Did you type in a question like that goes out to 4 places? I don't remember.
Don't remember. So a good way then would be to go back and check. I might have typed in 4.
No, you didn't. That's why I'm questioning. Why is that looking like that? Why does it
Yeah.
go out to 3 decimal places when you didn't type it in that way?
Yeah.
You only said 2 sig figs, and you only typed in numbers that had 1 decimal place. So why is that number going out to 3?
So even the sig fig feature doesn't get the sig figs right.
Because I remember your numbers only had 1 sig fig, and I'm like, why does that have?
Yeah.
1 decimal place. Excuse me. Why does your? So that's just a bad type of question then, in general.
Yeah. So I can show you the way that I use it, and then I think I need to wrap up here for today. But
I think you went through it already. I don't think you need to if you don't want to.
well, no, I'll show you the way that I do it, how I use the sig fig thing. Here's an example of how I might set one up. And so this here is one that uses the equation editor.
Mm-hmm.
And I don't randomize these variables. I put them in here myself because I want them to show up to students as exponents, not with the up carets.
They have just 1 question on that one. Then they don't have 5 variations. Then.
Well, and then what I do is I go through my calculator and I come up with several different examples, and I change the numbers in here, and then I change them in this formula. So my formula doesn't have any variables in it.
Right.
And then when I come down here for a variable, you still have to, you can't have 0 variables. So I just make up a variable, call it X.
Mm-hmm.
And I have it go from 1 times 10 to the first to 2 times 10 to the first by steps. So 1 times 10 to the first. But you'll see that X doesn't appear anywhere in the equation. And it's because
That's weird.
D2L, if you're going to do this, forces you to have a variable. And so I just make one up, but don't use it in the problem.
But then it doesn't do any calculation with it then, right? It doesn't even matter?
Right. The calculation that's being performed is this calculation here,
right,
which matches the one in the equation. So
okay. Since there's no variable, it's not going to use the variable you typed in, but you have to have one typed in. It won't let you do no variables.
right. And the reason why I do that is because I still want students to be able to write something in scientific notation. So I will still have a problem here where the students will write out a number in scientific notation.
Okay. So another question, in equation editor, where does it, when you do the formula water, like when you do H2O and stuff like that again, where is that again when you do the subscripts? That's just the normal subscript stuff, right? You don't need to use equation editor for that?
So you could just do the ordinary subscripts without using the equation editor. If you wanted to use the equation editor, then what we do, just write a new problem. Let's say that this one's going to be a short answer problem. And this one's kind of a good one to look at. We go over here to the equation editor, and then we could write in something like H, and then we could put in the subscript here 2. And whoops, we don't want another subscript.
Isn't that the hard way to do it though? Isn't there? I remember
it
there was
is.
an easier way. What was the easier way? You could just do it when you're
2O like that if you wanted to. But the easier way to do it, in my opinion, we go to the full screen editor here. We type in H, and then the subscripts are found right here.
Right. That's what it was. Okay, yeah. I did it before.
Yeah.
You use equation editor for that. Okay.
Yeah. So then you could put an H2, and then you have to unsubscript it here,
right,
O, to put it in.
So you can do it either way, but the easiest way is the second way you just showed, right?
Yeah, I think
That's
so.
how I've done it before. I just wondered if you could even do that in equation editor. You can, but it's more work. So.
Yep.
Okay.
Well, you've been a really good student, Patty. And
well, thank you, Lance.
And I am going to ask for your permission to post this to our group and share it for those that want to go back and review it.
That's fine.
And I'll provide a link to, like I say, anyone that wants to use this.